So I'm a statistician from Cape Town, and I'm going to basically talk to you today about my involvement in the super studies, and particularly in the analysis or guiding the analysis of these super studies. And we're going to focus on the impact of this parenting intervention on the harsh discipline practices. You'll see as I go, there are many other outcomes too, which we will be getting to. So as Jamie said, I'm a professor at the University of Cape Town. I got into all of this because I work with Professor Kathy Ward, who many of you will know, and we've had a long-standing collaboration on statistical analyses for many years. Most of the work is either done or is meant to be done by my master's student, Hayletje van Zyl, who's currently in Cape Town. And then, of course, I collaborate with all your wonderful colleagues in the GPI unit here. And so this then is a study that forms part of the Global Parenting Initiative, and there's Parenting for Lifelong Health and all of that, and you all know more about that. I'm the statistician. That is very nice when you give me very interesting data so that I can play with it as much as I wish. But I understand that parenting for lifelong health is really like a suite of 4 evidence-based parenting programs that is designed to prevent violence to children and improved child well-being. There are various programs. There's one for infants, for toddlers, for young children. I think the ones that we are dealing with is the ones for parents and teens. And there were many randomized trials that tested this intervention, but the exciting thing of the super study is that they have scaled this up and they've implemented these interventions in many countries as part often of bigger projects and bigger implementations in those different countries. And this now gives us the chance to see how does this work at scale and in different environments. And so there's just a map. Most of these countries were in Africa, some in the Far East, and a few in Europe. The sample sizes there are not the total sample sizes, but are the sample sizes of the specific cohort that the analysis that I'm talking about today are based on, but it gives you an impression of the variability in sample sizes from the different countries, some very large cohorts and some smaller cohorts. But in the end, of course, we're going to end up with a vast database. So I'm going to not only tell you whether this thing works or not, but also talk to you about, as an analyst, as somebody who's got to do the analysis of all this wonderful data, what are the thoughts in one's mind that you've got to think about to actually be able to hopefully get to the right form of analysis so that you can give results that are valid. And we're going to talk a little bit about the design underlying all this data. Then we're going to say we've got to decide which of these many studies or countries to include in our joint analysis. We're going to think a little bit about which subjects, caregivers and teens within the countries to include in our analysis. As I've said, there are many outcome scales, and there's going to have to be a decision on do we do them all or do we focus on some of them. Do we need to adjust our comparisons for any confounding characteristics, maybe subject-specific characteristics or others? You can imagine that there was an awful lot of data management to be done, and I'll talk a little bit about that. And then I'll move on to the statistics. What do we do when we just want to get a picture of what things look like, the summary statistics, the graphs, and then what kind of models do we fit when we want to get a little bit more sophisticated? And finally, give you what you're probably looking for, the preliminary results. So we're dealing with observational studies, anonymized routine service data, often implemented as part of larger suites of intervention. So nothing is nicely controlled like one would normally like. This is as close to real life data as you can get with all the problems that maybe go along with that. We hopefully have matched caregiver-teen dyads in that both the caregivers and the teens were involved and in this parenting intervention, and they were both surveyed in terms of their responses and their feelings before and after the intervention. There is no randomization. There is no control group. People, of course, act as their own controls before and after the intervention, with that 14-week intervention in between those two assessments. These assessments are based on self-report questionnaires that assess the caregiver and the child well-being using pre-validated scales. Now, given your discipline and the department you are in, you are used to that way of collecting data. As a statistician, that often actually analyzes medical data. More and more I'm getting this kind of data because researchers, especially infectious disease researchers, moved on to looking at changing behavior of people. But previously, I was used to analyzing exact data where you take a measurement of a biomarker and you make a blood test and you see, does that patient, is they infected with HIV or not, for example? Much stronger and cleaner data than self-report data. And then there is one country that had a slightly different design from the other countries, Botswana. And if we get to it, I'll see how the time goes. I'll talk to you about the implementation of that design and what that allowed us to do. But let me give you some idea of how we have chosen which countries to include in our meta-analysis. So we have the potential of 10 different cohorts of data in those 10 different countries, as you see up on your screen. Botswana is the country where we've got the different design, and in fact, Kelechi has analyzed that very nicely, and I'll show that to you towards the end of the presentation. The 3 studies that are underlined, the DRC, Tanzania, Zambia, and Zimbabwe, was the data available to me when I did this preliminary analysis. But we are still waiting for data from South Africa, mothers to mothers. We're not going to be able to use the Eastern Cape data because the scales are totally different from the scales that we measured in the other countries. And then in some of the countries, Eswatini, South Sudan, I said we had dyadic data, so we had caregivers and teens. So be able to analyze those together, we need to be able to match a caregiver to a teen. And you all know that the way in which you match it is through an identifying number. And it is just absolutely mind-boggling how poorly these numbers were captured in some of our databases. And so there are at least 2 countries, Eswatini and South Sudan, where we had real difficulty after many, many tries to necessarily do that matching. We can do it for some, which means we can analyze a subset, but you introduce all kinds of biases when one does that, and I'll get back to that. So here we are. So that brings us to which subjects do we include in this? We have 3 options, and we've spoken to the bigger team about these 3 options. We could include all caregivers and teens, regardless of whether we could match them, because we can just decide that they were both there, they both had the intervention, and so we get a general impact of it all. And that would be regardless of whether we could match caregiver to teen or whether we had pre and post assessments for all of them. Or we could say we would like to include only those caregivers and teens when we could match pre the intervention, so that at least we know we've got this diet together. And then we would analyze them regardless of whether they also had a post-assessment. And that is because our statistical models can cope with that missingness if we assume that missing measurement is at random, that there is no real bias involved in that missingness. And finally, we can be really strict and we can say, well, let's include all caregivers and teens when we can match to each other and who had data both at pre and post. And of course, as we go down that hierarchy, we're going to lose some people. Now, we haven't really got a problem with sample size. In fact, our problem is we've got too many people and in the study. But as you start losing people or you start losing maybe countries, you are introducing bias, because it might be that it's the countries that have conflict or the households that have maybe struggles in there that's dropping out and we don't get a good picture of what's going on. And so one has to be a little bit careful. For this analysis, I've used the middle one. So where we can match caregivers and teens at baseline, because that way we can use caregiver and teen characteristics to adjust our models, but not worried about whether they were at both the pre and the post. But for the bigger analysis, we'll be looking at those variations. So the data management, there was a lot of data management to be done. And I think one of your colleagues for the Tanzania study gave a very, very good talk a year or 2 years ago now about the intricacies of the data management. But you have to, not all the countries call the variable names or the scale names the same. So you've got to make sure that they are the same. You've got to make sure that what they've called it match the questions you asked on the questionnaires. You've got to validate the ranges. You've got to get rid of duplicate observations. You've got to merge the data, match them, reverse code some variables, create composite variables, and so it goes on. Luckily, at my stage of life, you give that to your student to do. But it is a real headache and not an insignificant part of what needs to be done. Unfortunately, it doesn't often make a very big part of your thesis, of course. It just allows you to get to that part where you can do it. So there were many different outcomes or scales measured in these super studies, and they are listed there.
Why?
And they mostly involve monitoring parenting or child behavior or support, stress, that kind of thing. We're going to focus on the last two, which focuses on harsh discipline. So there we've got the IPSCAN child abuse screening tool that basically asks responders to indicate the frequency of emotional or physical discipline in a certain period leading up to the questionnaire. And they use a 9-point Likert scale for that. And they have questions like, in the past 4 weeks, how often did physical discipline seem like the only option for stopping bad behavior? Or in the past few weeks, how often did you shout at your child? And the higher the scores, the worse the harsh parenting. So we had 2 items that measured physical punishment and 2 items that measured emotional punishment for all our scales, with the exception of Zimbabwe, where we only had 1 item within each of those scales. Then there was also the mix, 1 item from the mix survey that assessed the feeling or the attitude towards the acceptability of corporal punishment. And that was also on a Likert scale, where the higher the scale, the more the people were sort of approving of the need for physical punishment. So those are the outcomes that we're going to be looking at today. Of interest to me was just how do these components of harsh parenting agree with one another? So what I did here is a sort of just extra little analysis. Firstly, I looked at how if you just added all 4 items together to get an overall view of harsh punishment, how did that correlate with either the physical or the emotional scale? And you can see nice, strong correlations, which is not surprising because the 2 subscales are really just a subscale of the 4 items. But what was of interest, and I haven't really actually given this much further thought, is the lack of a strong correlation between the physical and the emotional scales that we have. And here it just shows it for 2 countries, the DRC and Tanzania, with physical, I think, on the y-axis and emotional on the x-axis. And sometimes you just get a random scatter, which is kind of interesting. So I need to think a little bit, we probably need to think a little bit more about that. Okay, so we got to the stats. What are the stats we're going to do? And previously, I had a long, various slides on the stats and realized that I should maybe rather say to you, you can come back to me and ask for details for those of you who would like them. But essentially, the stats is based on you either need to summarize and display, and that's very important and to do because you need to get a picture of what's going on, and then you want to model. And so you will see in a minute that the summary statistics and the graphs are in the form of bar charts or box plots of medians and interquartile ranges that somehow gives one an idea of the level of the punishment and how it changes from pre to post. Then when we want to start modeling, we need to decide on, firstly, what is the underlying distribution of our response variable, our response variable being that total scores that measure physical or emotional punishment. And given what the underlying distribution is, we can choose one, and we can then fit a regression type model with that a specific distribution, and adding what we call a random effect to account for the fact that we've got this correlation between pre and post measurements. So that falls under the area, for those of you who are a little bit more quantitative, generalized linear mixed effect models. And I spoke to one of you earlier on. You know that for count data, that's often a Poisson or a negative binomial. And for continuous data, it's a gamma or a log normal. But there is a magic distribution called the Tweedy distribution that incorporates the Poisson negative binomial and some others within it, and is actually really, really useful for modeling outcomes that have got long tails to the right. So lots of low values with a few large values, and I can give you more information on that. But that's what I used, that and the negative binomial, for what I'm showing you today. Also have to decide, how do I want to interpret my outcomes? Do I want to have an absolute effect or a ratio effect, a multiplicative effect? And we aimed for a multiplicative effect, which meant that we use the log link in these models. And when we then take the exponent of the coefficients, we can tell you a percentage change, which one can often understand better. It is also the natural mathematical link that goes with these distributions. So let's see what all of that is showing us. Here, this slide is for the total I-cost scale. So when I took the 4 items and I added that together, and it's essentially just the prevalence of the different scores, the 1, 2, 3 to 8 for the individual items. We've got the pre-scores there and the post-scores there. We've got it for the caregivers and the teens within the different countries. Blue is good. Red is bad. And what we want to see is for the red to get less as we go from pre to post. And that is happening. You can always see that the red bars are getting shorter from pre to post. So that's the one good thing. It looks to us as if the frequency of harsh punishment is decreasing from pre-intervention to post-intervention. That is also true for the mix statement that talks about the attitude regarding the acceptability of harsh punishment. The rate definitely decreases there, never was there, I'll get back to that. It decreases everywhere, except maybe among caregivers in the DRC when it didn't. So overall, we see a decrease in that attitude, but there is variability or heterogeneity in that response a little bit. And then the other one is that even before we did this intervention, there were, of course, different levels of harsh punishment in these different countries. You can see that Tanzania had much lower levels of harsh punishment before the intervention than, for example, the DRC or Zambia. And interestingly, Zimbabwe, after the intervention, seemed to be behaving perfectly according to the responses that we got. So there's between country variability as well. These are the underlying distributions of the total score within the different countries. And now you can see, firstly, those skew distributions that I talked of, the distributions with the tails to the right. The bars being wider for the DRC because it was a much smaller cohort, so smaller sample size. You get the box plots that shows you the medians and interquartile ranges, pre and post, and you can see how the medians, the lines across the boxes, they are going lower from pre to post intervention for the teens and the caregivers. And the other thing is that the boxes are becoming narrower as we go from pre to post. And if you really do just want to do some very simple statistics, so cross-sectional statistics, where you're not taking into account the paired nature of the data, you can calculate medians and interquartile ranges, and you can do some non-parametric tests to say to you whether those are the same. And it's basically showing you that those medians are getting lower post-treatment, and that most of the time those p-values are as small as you would like them to be. We did the same for the component scores, so the physical and emotional ICAST scores, and then the mix assessment. And we did that in the 4 different countries. And you can see the same thing happening there. We get skew distributions, and the skew distributions I'm seeing here, not with a histogram, but with these box plots that have got these long tails ups and no tails at the bottom. So it's a different way of seeing that. But definitely decrease from pre to post, as I already have explained. Those lines, those median lines are going down from pre to post. And we see more variability, wider boxes at the pre than the post. So what the intervention has done is to make behavior more consistent, which makes sense. You would hope if you've gone through a program, you're behaving more alike than before the program. There is less change in the emotional scale than the physical scale from pre to post, and especially so in the DRC and Tanzania. But we did also see that as I go on with the models a little bit, and to my mind, and I'm now on your ground, not my ground, I guess that makes sense too, that maybe it's going to be easier to stop the smacking than the shouting, so to speak. And then the attitude towards harsh punishment also showed a decrease, but a large variability in the DRC here with wide boxes. But that's a small sample, so we're going to see more variability, but it's also a little bit of a more complex country. So that's not surprising. You also notice the different way in which I analyzed the mix score for Tanzania, because it was just the binary data there as opposed to a score. So that's all the things you have to take into account when you do more countries than one. Okay. So that's the answer. We don't need to do any more. You've seen that it works. But of course, that's not quite where we're going to stop. We're now going to formally test that and do the statistical modeling and inference that is needed. And before we do that, we need to think about the possibility of confounders and moderators. So a confounder messes up the association between an intervention and an outcome, whereas a moderator changes the way in which the intervention works, which from a modeling point of view means you've got to, if you want to adjust for confounders, just bring the confounders into the model, and you're not really too interested in what they are doing, but you're interested in how they're changing the association between your intervention and your outcome, when they're in and out. Whereas the moderators, you would have to bring in an interaction into your model, because you actually want to estimate different effect sizes for the different levels of the moderator. And that's not unlike doing a subgroup analysis for the different levels of the moderator. So the confounders, or the potential confounders available to us, are caregiver and teen demographic characteristics, and then some data on their well-being and on their drug use and on the level of conflict in the house. But we did not have that across all the countries. In fact, in some of the countries, the DRC and sometimes Zimbabwe too, we only had the caregiver and teen, gender and age. So for this specific analysis that I'm showing you today, I have only adjusted the models for caregiver and teen, gender and age. But of course, one could expand that to a subset of countries for which we have done more. However, I do believe that it's probably all those other data, the data on well-being and on conflict and so on, is going to be of more use when we're interested in homing in on certain subpopulations, so that we can tell the WHO or whomever, look, this also works within this population. And so some of the subgroup analyses that we plan to do is to look at how it works for male caregivers, to adolescents with their own children, children with disabilities, maybe if there is TB and HIV infection in the household, and does it change for when we have girls rather than boys? But here we've got a model. I fitted here, I think it was mostly a 2D model. Here I'm showing it just for the DRC, but I repeated this for every country. I analyzed the physical, emotional scores and the mix score. I did it unadjusted, meaning I just brought time into the model. So if I bring time into the model, it's really just comparing pre to post, or post to pre, I should say. And then I adjusted it for those caregiver and teen demographic characteristics that I saw. And what is it showing us? Well, the first thing is, remember that we were looking at ratio effects. So when you get an estimate of 0.25, what it means that there is a 75% decrease in the physical score from pre to post. Similarly, for the emotional punishment, there is a 44% decrease from pre to post. If you look at the adjusted models, then here are all your covariates in addition to time, and the only one that really stood out in its own association with our outcome is that of the male teens, that there was a higher level of physical punishment when you were dealing with a male teen than a female, a girl, and that happened pre and post. So, and that's sort of, I guess, something that makes sense as well. But if you compare the effects, the time effect, which is just comparing the impact of the intervention, and you look at it in the models that I did not adjust for confounders and the models that I did, there is hardly any difference there. So we don't have much confounding there due to these characteristics. We might as well, in this particular case, use the unadjusted estimates. They didn't change anything at all. For the mixed scale, we also had a 40+% decrease. There it did change a little bit when I adjusted it from 0.56 to 0.6, but overall a 40% decrease. So our intervention works, which is great news for everybody, of course. And then at the bottom, you see all of this. And again, it's for those of you who are going to start fitting statistical models. We can't just fit a model and give you results. We need to check that the model is valid and that it satisfies all the assumptions that before we can tell you what the good news is. And we do it through some diagnostic plots, and these plots are telling us that everything is all right. And again, if you are going to fit these models yourself, I can point you to a very nice new R routine that provides these plots for generalized linear models. You can just get in touch. So I did this for all the different data. But this is actually a meta-analysis. We're actually combining all the studies. So now we've got to think, what kind of approach are we going to apply to this meta-analysis? And those of you who've done meta-analyses before have probably all done it based on, or mostly done it on published data. So you do a systematic review. And from the relevant papers, you extract the effect sizes and the measures of their uncertainty or variability, and then you put it into a meta-analytic model to come up with a combined result. But we've got all the data. So there is nothing really stopping us from putting all the data together in one large data set and analyzing that together. And that is what would be called one-stage meta-analysis. And there are pros and cons to using that. Alternatively, you can still analyze each country separately. And then you can combine those estimates that you now yourself are generating for these individual countries using the meta-analytic models that you're used to doing. And for now, we've gone for the second option, so the two-stage meta-analysis, because there is a lot of interest in the results within the specific countries as well. I can get that out from a big model that I have fitted on the combined data, but it will be slightly more complex for anybody to read and get. So we're going for a two-stage model at the moment. It gives us the country results very nicely. We can still compare countries with one another by just looking at the confidence intervals. And it also shows us which countries maybe are behaving differently from others. So it shows us the heterogeneity in our results. And this is really the slide you want. And it's a little bit small, but here we have our forest plots for physical punishment, emotional punishment, and the mixed scale. And of course, we've got it for the different countries, and we've got it for the teens and the caregivers, and then we've got the overall combined risk. It's called the risk ratio here, just because that's what our procedure call it, but the ratio effect and its confidence interval or its prediction interval. You also know that a meta-analysis, when it combines these different estimates from different countries, it is a weighted analysis. If you look at the weights, you'll see that the DRC had a relatively low weight compared to the other countries. So its impact was less. It was partly due to its smaller sample size and hence its bigger variability. But the story is a good story. Here's your point of no effect, the line of 1. This is where the combined effect is much to the left of 1, so a great reduction in the level of harsh punishment. And the confidence intervals are all also to the left of 1. So we have got, if you really want to know, a statistically significant decrease in the level of harsh punishment. That is also true for the overall effect. The prediction interval, which sort of says, well, if you had to take this and do it outside the sample of your data, you'll have a little bit more uncertainty. Will you still get this result? And you can see that that interval just goes over the point of equivalence, but the majority of it still lies to the left. There is significant heterogeneity in that you can see that, for example, Tanzania, that point estimate in the block is much higher and further removed from the others among the teens, and in the caregivers, it's the DRC and Tanzania that behaves differently. Still all to the left, still all good news, but different levels of magnitude. Tanzania was the country where they started off with relatively low levels of harsh punishment, and I suspect that that is part of the reason for what we're seeing here. The DRC, so my colleagues tell me, is a country with lots of conflict in there, and that might be some of the reason why we see different results there. But overall, 71% reduction in the severity of harsh physical punishment, 60% reduction in emotional parenting, and a 52% decrease in the mixed score. And there you've got the results and the meta-analysis. The problem is, that's all good, and you can go and tell the world that this is great, and look, it works, and they're going to say to you, but there's so much confounding here. You haven't randomized, you haven't got a control group. What are you going to do? And so I want to introduce to you the idea of e-values. I don't know who of you have heard of e-values and have used them. It's relatively new to me. In fact, the reason why one either agree to review papers for publications, or you publish papers and you see what the reviewers tell you, is because you learn all these things. And in a totally different student in a different area, when we submitted a paper, they said, why don't you do an e-value? So if you've got an observational study, no randomization, no control group, lots of potentials for confounding, especially unmeasured confounding, is there something that you can do about it? And what e-values do is it answers the question, how strong would this unmeasured confounding have to be to negate the findings that you're busy reporting at the moment? So confounding is when that unmeasured variable has a strong association with, in this case, your intervention and with your outcome. And you really want to know how strong should that association with the intervention and the outcome be for you to start saying, I don't believe these results to the same extent anymore. There is a formula to calculate it, and there is a way in which one can derive that formula. And the nice thing about it is that the minimum value is 1, which means that the bigger the e-value, the safer you are. The more you can say that you need a really strong, unmeasured confounding effect before you're going to say you don't believe your results. Of course, if your ratio effect is less than 1, you would first invert it before doing this e-value calculation. You should also interpret the e-values in relation to the strength of the effects that you have in your data. So if you've got large effects, then you of course need a much larger e-value, and the other way around. And then you can also apply it to confidence intervals, so that you can say by how much that lower confidence interval has got to be moved before now you're going to include 1 in your in your confidence interval, you're not going to have a statistically significant effect anymore. So luckily for you and for me, I don't have to do that calculation, though it is a relatively straightforward calculation to do. There, of course, as always, is an R library or package that's going to do it for you. And whilst R is not the easiest software to use, and there's a steep learning curve, the nice thing about it is that everybody puts whatever they've done there quite quickly, and so you can use it too. So there's a library eValue, which you can go and look out, and there is some relatively simple syntax where I just grabbed the values from the R object where I stored those estimates, and out popped my e-values. And here I get an e-value of 6.3. You recognize that 0.29 is the ratio effect that I had for the decrease in the physical punishment, and now the e-value is 6.3. So what it's telling me is that residual or unmeasured confounding could explain the observed association if there exists an unmeasured covariate having a relative risk association at least as large as 6.32 with both the intervention and the outcome, which is 6 is quite big. It's lots bigger than 1. Difficult to interpret that in relation to that 0.29 because 0.29 is less than 1. So if we invert it, then the equivalent inverted ratio for 0.21 is 3.43. And the 6.32 is twice as large as the 3.42. So you need an association of an unmeasured covariate with your intervention and your outcome, at least twice the size of this observed association that you have found between your intervention and your outcome, before you're going to say you're not so sure about whether these results are true or not. And so that fills you, hopefully, with a little bit of confidence. And when I calculate the e-value for the lower confidence interval, then it shows that that lower confidence interval should be 3.67, so about the equivalent of your effect size before it might start moving and including the point of equivalence for the unmeasured confounder. And I did that for the emotional punishment and the mixed scales as well. And in all cases, it was true that roughly you needed an unmeasured confounding twice the size of the effect size that you've observed for you to get worried about your results. And so that's good news for us. One other thing that I've done and that I just wanted to sort of put there and still play with it these days, it's weird how certain methods are in vogue or not in vogue, and certainly in medical statistics where I mostly work these days, if anybody asks you anything, they say, oh, you should do latent class analysis for us. And it's a data-driven technique, and of course it's all about data science and everything else these days and so on. But what it essentially does, it allows your data to suggest whether actually there are different trends contained within your data. So are there different degrees of decrease that you're seeing, as opposed to just a single level of decrease that you've estimated with a confidence interval? And when I did that for the teens and the caregivers, just I think that's right, I put all the countries together. So I now have my 4 countries all in one large data set. But I am allowing the data to estimate these trajectories without any reference to any characteristics, or which country it comes from, whether it's a boy or a girl, any of that. I identified potentially 3 different trajectories, and this was for the total ICAST score. One that starts very high and has quite a steep decline, one that had a relatively low level of harsh punishment to start off with and decreased, but to a lesser extent, and one that indicate really that there was no real prevalence of harsh punishment before or after. When I allowed a 4th group to be found, and we can talk about what are the optimal number of groups, then suddenly it identified a group that maybe increases, a group for which this didn't work. Now, the exciting thing or the interesting thing about this would be to go and find out what are the characteristics of the subjects that fall into those different groups. For example, this middle line here is Tanzania, where they had a relatively low level of harsh punishment, and hence the decrease was smaller, for example. But of course, very interestingly, which is the group maybe that didn't work for, that increased. And And that's something that still needs to come. One now uses these categories, these outcomes, and as your outcome, you do a multinomial logistic regression. You define the predictors for those, and it's something we're still going to do. But that will help us potentially in describing the reasons for the heterogeneity in our estimates. And that is sort of how we're going to do the meta-analysis. We're now going to extend that to more than our 4 countries. In fact, I have brought in Eswatini and the other small country, and the message is it still works, okay, which is good, but we're nearly ready to get going with all the others. The mothers-to-mothers data is just about, I think, in our inbox now, so that will be very cool to do. I have a little bit of time left, and I just want to very briefly touch on the Botswana. I don't think I'm going to get through it all, but to talk to you about this different design, a step wedge design that was implemented in Botswana, and how Heletje went about analyzing that. So in Botswana, this study was implemented by the Penegare group, and that was as part of a big study, but they were very, very engaged in the analysis and in the data collection, and it's been quite nice working with them. So what are step wedge designs? They're cluster randomized trials, so you're all familiar with cluster randomized trials where you randomize the clusters as opposed to the individuals in a cluster. It's increasingly being used to evaluate service delivery or interventions. It involves a random and sequential crossover of clusters from the control to the intervention. So you will have randomized, you would have randomly selected groups of people, and the first group will get the intervention now, and another one later and later, and I'll show that to you in a minute. It's a pragmatic study design. It can reconcile the need for robust evaluations with real-life problems like political or logistical constraints when you're implementing it. It's not exclusively for the evaluation of service delivery, but it's often used for that. This is what it looks like. So you've got a study population that is divided into different clusters, and you sample people from that clusters, just like we always sample. We never, seldom analyze the whole population. But then you're going to have a basement assessment of the selected people in all of those 4 clusters, for example. Then at the next time point, the people in the first cluster is going to have had the intervention, and you're going to now assess that intervention, whereas the other 3 clusters are still under control scenarios. And then you go like that in a stepwise fashion until everybody has got it. And the nice thing about it is that at different time points, you actually now have people that have had the intervention, and you've got control groups, theoretically. But of course, the problem that it is that there is potential confounding by time, and we're going to talk about that in a minute. And the randomization is cluster-based. So whether you're going to get the intervention early or later depends on which cluster you are in. You are not randomizing the individuals, you are randomizing the clusters. So the people in Botswana, I don't know the reasons why they wanted to do a step wedge design, but Kathy could have told you all about that. But they planned it very, very nicely, as this graph is showing you, or the schematic is showing you here. They were going to implement this in different waves. They had different districts, and within the different districts, they were going to have different clusters, and you can see the very nice stepwise manner in which they were going to increasingly subject these different clinics or whatever within the districts, within the clusters, to the intervention. But life interfered, and it didn't work that way. This is, roughly speaking, what worked. So the study started in 2020. There was a long basement period, and then there were the sequential implementations of the intervention and the assessments of how that worked. The difference between what this is meant to be showing you and what the previous graph is showing you, that we didn't have the clear steps. They were rather intervals in which these changes were happening, and these intervals sometimes overlapped with one another. So there was potentially a chance of sort of residual contamination, so to speak. And then there was not a cluster, but a one delayed district that started a little bit later than the rest. Of course, it was during the COVID years and all of that. So there was a lot of it that came. So we had to take into account, we had to analyze this data and see whether we could adjust for all these impacts of these different times. The fact that not everybody would be measured at the same time since the intervention, for example, for the post-intervention, and so on. And I'll show you how we did that if I rush. We had these three clusters. Now, cluster one, which is the cluster that got the early intervention, would just have had a pre-assessment, a post-intervention assessment, and then a delayed end assessment. Cluster 2 would have a baseline assessment, but would not go on the intervention immediately, so would have a second assessment pre them having the intervention. Then they had the intervention, they had a post-assessment, and then an end assessment to a bit later on. And cluster 3, that was the one that got the intervention last, would have had the baseline assessment and the pre-assessment, but that end assessment was their post-assessment because they were now the last ones in the study. So the nice thing is that cluster 2 will be able to tell us whether anything changed from baseline to pre when there was no intervention. Then you've got the pre to the post, which is really the strict evaluation of the intervention. And then the post-intervention to the end is testing the durability of the intervention, which is rather nice to do. And what one hopes is that there won't be much change between baseline and pre, that we'll see a decrease from pre to post, and then interested to see what happens to that decrease. And in fact, it seems here in this specific case as if it endured, so to speak. But we'll look at that in a little bit more detail. This was for the caregiver ICOS. We here do it for the total ICOS score. We haven't yet done it for the component scores. This is for the adolescents. Again, no difference at baseline and pre, a decrease from pre to post, and that decrease persists to the end. The mix for caregivers, the same story again, not much of a difference here, definitely a decrease there, but interestingly enough, a slight increase maybe in the red shade from pre to post, so that this attitude thing didn't seem to persist as much as the other two scores persisted. And we can see how that unfolds in the modeling. So when we had to then do the models, we had to think very carefully what kind of models, and Helechi fitted 11 different models, but essentially you can just compare intervention with non-intervention. So you can just put all this data together, and when they did have the intervention, you have a 1, when they didn't have the intervention, it's a 0, and you throw it all together. Or you could be a bit more specific and go according to the planned design and say, I'm going to compare baseline assessment to pre-assessment, post-assessment to pre-assessment, and end assessment to pre-assessment, and see what the different sizes are. But we've got this problem with time, and there are two problems with time. There is sort of what we call the exogenous time, which is just the fact that the calendar time moved on from July 2020, and things may have changed, and we would like to see whether that calendar time impacts on how things were measured and how they worked. And then we've got the problem that within each cohort, we didn't have these single points of assessment, pre, but especially post. There was a range, this interval, and so for some teens, we might have measured the impact of the intervention longer after the intervention than others, and we call that the endogenous confounding, and we would like to see whether that had an impact. So we had these models where we brought those times and their interactions in. Quick results. This is the very simple model that basically compares the endpoints to the pre-points. So these wide lines here are for teens and caregivers, the ICOS total, baseline to pre, and you can see that these confidence intervals very much include the point of equivalence, so there was no real difference to worry about between pre and post. Whereas when we compared post to pre and end to pre, our effect sizes and their confidence intervals are now very much to the left of 1, meaning that there was a significant impact, and that impact persisted from the post-intervention to the end. Maybe slightly less strong, but for all practical purposes, not a problem. And that happened for the mix as well. I'm rushing, so I'm not going to go through that. I just wanted to show you then also a model where we brought the time in. So if you bring the time in, you've got the intervention, you've got the time, in this case since baseline, we're looking at our exogenous time, so the time since June, July 2020, and then we've got the interaction. Now you see that the intervention is a very small number, very much less than 1, so it's still telling us that this intervention worked, that the post values are much lower than the pre-values. But because we've got this interaction, that is very early on in this long calendar period, so around about June, July 2020. The interaction effect, 1.096, is a little bit larger than 1. So what that means is as time moves on, it's carving away at that effect. It's making that effect moving nearer to 1. And what we then did is we evaluated the size of the intervention at different durations since the 1st of June 2020, and I think that was model 3, and you saw it getting smaller, meaning you're getting nearer to the point of equivalence, but it still stayed within the less than 1 interval. We did the same for the endogenous time, so that meant how long since your exposure have you now has elapsed when you now measure the impact. And the same thing happened, that the further you move away from the exposure, the more that effect size is decreasing a little bit, but it's still staying very much to the this is a good intervention kind of thing. And this was for the caregivers, and this is the mixed scales. It basically the same story held there, that there is some impact of time, but at the moment not too much. There is some that I can home in on where you see confidence intervals start overlapping 1, especially with the mix for adolescents. Adolescents data are more variable, and so it's not really surprising. I'm going to skip these, but Botswana, the step wedge design also includes, although it's meant to be cross-sectional, it does include a longitudinal component, and we could analyze the longitudinal component and see whether we get the same results, and we did. And as I showed you right at the beginning, it allows you to look at these pre-post comparisons at different time points. So you now have a control group, and we did that, and we found that also confirmed our results, basically. So we still have a very successful intervention, in this case in Botswana. Yeah, and so that is basically where we are. Parenting intervention had a positive effect on decreasing the prevalence of harsh parenting. It also decreased the attitude towards the acceptability. That was true for caregivers and teens, but the teens, of course, are more variable. There is some evidence of a decreasing effect size over calendar time in Botswana, and there is also some evidence of a decreasing effect within each cohort-specific window of assessment time in Botswana. But in general, the impact of the intervention remained significant. There may be a strong cluster effect in Botswana. And at the moment, we've just incorporated the clusters as random effects, but I am wondering, we've only got 3 clusters, whether we shouldn't include them as fixed effects in the models and examine that difference in the cluster effect more. And I'm sure the people on the ground in Botswana may well be interested in that. We've seen some heterogeneity in our results, and it may be interesting to compare that. But that's all for now. Thank you very much.